Hi everybody. Hope you guys had a great spring break. It was really nice reading your responses on Monday to the questionnaire or the survey that I gave you for your assignment on Monday. It was nice hearing about all your spring breaks. It was interesting to hear that some of you actually did just sit and stare at the wall all day, which just sounds boring. But it sounds like some of you guys were still able to have some somewhat good spring breaks despite having to stay inside all the time and all that. Thank you guys for your thorough responses. I did respond to a lot of your responses in Canvas, so feel free to go in and check my feedback to your questions. We do have, I want to say that like including today, like 16 more classes in the school year. I'm not sure how much we're going to get through. I'm thinking we'll at least be able to get through chapter 11, which is what we're going to start today. I don't know if we're going to get to chapter 12 or not, but this might end up being the last chapter of the year. So let's go ahead and get started. Today we're on to lesson 11.1, which is simplifying rational expressions. Okay. Our objective for today is to simplify rational expressions. Okay, so rational, think rational is fraction, right? So we got rational expressions on top and bottom of a fraction. All right, now an expression of the form a polynomial over a polynomial is considered a rational expression. It's some sort of a fraction. Okay, the simplified form of a rational expression is like the simplified form of a numerical fraction. The numerator and denominator have no common factor other than 1. So basically our whole goal today is to be able to simplify fractions with polynomials on the top and bottom. Okay. To simplify a rational expression, divide out common factors from the numerator and the denominator, in which you may need to end up factoring it in order to be able to divide out common factors. And then like a numerical fraction, a rational expression is undefined when the denominator is 0. So if anytime you have the 0 on the bottom of a fraction, it's undefined. Okay. A value of a variable for which a rational expression is undefined is an excluded value. All right, so our first example says, what is the simplified form of x minus 1 over 5x minus 5? So we've got x minus 1. That's already simplified. 5x minus 5, we want to look at this GCF here to see what we can pull out of 5x minus 5. Well, the GCF of 5x and negative 5 is 5, right? So I can pull out a 5 from this and make it 5 times x minus 1. Well, we have an x minus 1 on the top and the bottom. These x minus 1s can cancel out. So now we're just left with 1 on top and 5 on the bottom. So the simplified form of this expression is 1/5. Okay. So I want you to go ahead and try the got it problems here. Try each of these on your own and see if you can get these. And then we'll kind of go over a couple of them together. All right, so hopefully you took the time to actually work these out. Let's go over just a couple of these. I don't want to take too long on all these. Let's go over A here. So 21a squared over 7a to the third. So first you want to look at the numbers, 21 and 7. 21 over 7 reduces to 3 over 1. So 3 over 1. And then a squared over a to the third. Well, the 3 is bigger than the 2, so our a to the first is going to be on the bottom. Now you don't have to write 3 over 1a to the first, right? If you have a coefficient of 1, you don't have to list it, right? So this is going to be 3 over, and then a to the first can just be written as a. So 3 over a should be your answer there. Okay. Let's go ahead and do D. This one looks like it's the most complicated one, right? So first, let's look at the top, 26c cubed plus 91c. What GCF can we pull out of? Well, what's the GCF of 26 and 91? Well, that's a good question. Think about what numbers can go into 26. Well, we've got 13 and 2, I think, are really the only factors of that, and 26 and 1. Okay. Is 26 a factor of 91? No, it's not. Okay, what about 13? Is 13 a factor of 91? Would it be 7? What's 13 times 7? 21, 91. So 13 then is a common factor. So let me go ahead and erase this stuff here. So our common factor here is 13 for the number, and then we've got c cubed and c, so we can pull out a c from those as well. And then we're left with a 2c squared plus 7. Okay. Over, we've got 2c squared plus 7 on the bottom. Okay, we've got 2c squared plus 7 on the top and the bottom. These can cancel out. So we're left with 13c over 1, which is just 13c for our fully simplified form. Okay. All right, next example. Here, simplifying a rational expression containing a trinomial. Okay, so whenever we have trinomials, we might need to factor here. So it says, what's the simplified form of 3x minus 6 over x squared plus x minus 6? State any excluded values. Remember, the excluded values are the things that that are what x equals, so that the bottom would be a 0. Remember, the bottom can't equal 0. So whatever x would be to make the bottom equal to 0, that would be an excluded value. Okay. So first, the top. We want to factor out the GCF first. So 3x minus 6, we have a GCF of 3. So it becomes 3 times x minus 2 on top. On the bottom now, we've got x squared plus x minus 6. Okay, now we want to factor this. Okay, so we want factors of negative 6 that add to a positive 1. Okay, well, what factors of negative 6 add to positive 1? That's positive 3 and negative 2, right? So we could split this up into x plus 3 times x minus 2, right? 3 times negative 2 is negative 6, and then 3x minus 2x is positive 1x, okay? So now we've got x minus 2 on top and on the bottom, which we can cancel out, and then we're left with 3 over x plus 3 on the bottom. By the way, I forgot to mention this at the start of the video. As usual, when we take our quiz and our tests later on, any notes that you take over these lessons you can use on the quizzes and tests. Just a reminder in case you forgot. So make sure you're taking good notes over all this because you will be able to use those on your quizzes and tests. Okay, go ahead and try each of these on your own and see how you do. Go ahead and pause the video and see how you do. All right, so again, I'm just going to go ahead and do A and D again just to save time. Ooh. Okay, so A and D. So A, we've got 2x minus 8. Okay, so we can pull out a 2 from that and make it 2 times x minus 4 on top. On the bottom then, we want to factor this trinomial. We want factors of negative 8 that add to negative 2. Okay, so let's think about our factors of negative 8. We've got negative 1 and 8, 8 and negative 1. We've got 4 and negative 2. We've got negative 4 and positive 2. I think that would work, right? 4 and negative 2. 4 plus negative 2. No, sorry. I want negative 4 and positive 2 because those add up to negative 2, right? So then my factors would be x minus 4 times x plus 2. So I've got an x minus 4 on top and bottom that I can cancel out. So then I'm left with then 2 over x plus 2. Okay? All right. D, we actually have two different trinomials that we need to factor. So first, let's look at the top. We want factors of negative 6 that add up to negative 1. Okay? So factors of negative 6, that would be negative 3 and positive 2. Negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1, right? So on top we're going to have c minus 3 times c plus 2. All right, now on the bottom, we want factors of positive 6 that add up to a positive 5. Okay? Oh, you know what? Hang on. We need to go back to this real quick. We forgot to list the excluded values. Let's go back to the original. So stating excluded values. So this right here. Okay, the excluded values are the values for x that would make this bottom equal to 0. Okay, what value of x would make this bottom equal to 0? Well, negative 3 plus 3 is 0, right? So if this is our solution, we know that x then cannot be equal to negative 3, which means that negative 3 is called an excluded value. Okay, so this one right here then, this first one, our excluded value, x cannot equal negative 2. We would have an excluded value at negative 2. Because negative 2 plus 2 is 0, and we can't have that. Okay? All right, so let me erase some of this stuff. I kind of marked over some stuff here. So let's see if we can factor now the bottom here. So our factors of 6, we've got 6 and 1, 3 and 2. The only thing that adds up to 5 would be positive 3 and positive 2. So we're going to have c plus 3 and c plus 2. So now we've got 2, c plus 2 on the top and bottom. We'll cancel those out, which gives us a solution then of c minus 3 over c plus 3. Okay. Well, what would our excluded values be then? We've got one excluded value. It's the thing that makes the bottom equal to 0. Okay, c cannot equal negative 3. We've got one excluded value, that's negative 3. Okay. All right, problem 3, recognizing opposite factors. So the numerator and denominator of this fraction, we've got x minus 3 over 3 minus x are opposites, right? X minus 3 is the opposite of 3 minus x, right? To simplify the expression, you can factor negative 1 from 3 minus x to get, so if we took negative 1 from this, 3 divided by negative 1 is negative 3. Negative x divided by negative 1 is a positive x. So then this becomes negative 1 times negative 3 plus x, which you can rewrite as negative 1 times. So if we just flipped this negative 3 and the positive x, it becomes x minus 3. All right? So then basically we have x minus 3 over negative 1 times x minus 3. Right? The x minus 3's can then cancel out, which then gets us positive 1 over negative 1, which is just negative 1. Okay? All right, so this says, what's the simplified form of 4 minus x squared over 7x minus 14? State any excluded value. So 4 minus x squared over 7x minus 14, we can factor 4 minus x squared to 2 minus x times 2 plus x. Remember, this is a difference of two squares. Remember, this is one of those special rules where you have a perfect square in the first number, perfect square of the second number, and then you're subtracting them. Difference of two perfect squares. So basically, you take the square root of the first number, the square root of the second number, and then one of the factors is going to be plus, one of them is going to be minus. So that's how we get 2 plus x times 2 minus x. Okay, hopefully you guys remember that, us doing that before. Okay, now factoring the bottom, we want to factor out a 7. It's going to be 7 times x minus 2. Now, here's where it gets tricky. You might think, oh, there's no common factors here, right? Well, we've got 2 minus x, and then we've got x minus 2. Using what we just did, if we factor a negative 1 out from 2 minus x, okay, so let's say we do negative 1 on top now, factor out a negative 1 from the 2 minus x. So 2 divided by negative 1 is going to be negative 2. And then negative x divided by negative 1 is going to be a positive x. All right? And then we've got 2 plus x over here. Oops, 2 plus x. Okay. On the bottom then we still have 7 times x minus 2. Okay, well, negative 2 plus x is the same as x minus 2, right? So this and this then can cancel out. Okay, and what that leaves then is negative 1 times 2 plus x on top over 7. So negative 1 times 2 plus x over 7 is then our simplified form of this expression. Okay, are there any excluded values here? No, there's not, right? Well, actually, unless we go back to, if we go back to this original one, okay, we don't want to look at this. If we go back to this original, if we plug in 2 here for x, it becomes 2 minus 2, that's 0, and then 0 times 7 is 0. So actually there is, if there is an excluded value, x then cannot equal 2. So there's one excluded value. So this is our simplified form where x cannot equal 2. All right, go ahead and try these 4 examples on your own. Pause the video, and then I'll go over a couple of them here in a second. All right, so let's look at this first one. We've got 2x minus 5 over 5 minus 2x. These are opposites, right? So let's say I do negative 1. If I factor out a negative 1 from the top, 2x divided by negative 1 is negative 2x. And then negative 5 divided by negative 1 is a positive 5 over 5 minus 2x. Okay? 2x plus 5 then is basically the same as 5 minus 2x, just written differently, right? So if I were to flip these two around, it would be, so negative 1 times 5 minus 2x, just by flipping those numbers around, over 5 minus 2x. Okay, these then can cancel out, which leaves negative 1 over 1, or just negative 1. Okay, and I don't know why I decided to write so big and take up the entire slide here, but I'm going to go ahead and erase this stuff. Okay, let's go ahead and do D then. So we've got 3 minus 3z over 2z squared minus 2. Sorry, this is the third video in a row that I'm recording and my throat is getting sore. So the top, we can factor a 3 out, right? So it's going to be 3 times 1 minus z. On the bottom, we can factor a 2 out. Okay, and it becomes 2 times z squared minus 1. Now you might think, well, man, even if we pulled out a negative 1, it still wouldn't be able to substitute anything, right? Or cancel anything out. Well, we want to think of this z squared minus 1. What do you notice about those? Z squared and 1, those are both perfect squares. What we can do here is we can make this, we can do the difference of 2 perfect squares that we just did, right? So 3 times 1 minus z on top. On the bottom we've got 2, and then this is going to be z plus 1. Sorry, this is a z plus 1 times z minus 1. Okay. Now, again, there's nothing here that we can cancel out yet. Let's say we pull out a negative 1 from this, though. So this then becomes, if we pull out negative 1 times 3 then is negative 3. 1 divided by negative 1 becomes negative 1. And then negative z divided by negative 1 becomes a positive z over 2 times z plus 1 times z minus 1. Okay? So negative 1 plus z is the same as z minus 1. So this and this cancel out. And then we're left with negative 3 over 2. This is a 2, not a z. And then this is a z plus 1. I forgot to do the excluded values on the last one. It's okay. This one I will. Okay. What can z not be equal to here? Okay. Z plus 1. Z cannot equal negative 1. If z is negative 1, negative 1 plus 1 is 0. 0 times 2 is 0. We can't have 0 on the denominator. So this is our simplified form then. Negative 3 over 2 times z plus 1, where z cannot be equal to negative 1. Okay? All right, last example. I think, yeah. Last example. You are choosing between two waste baskets that have the shape of the figures at the right. So we've got one waste basket that's a cylinder, one waste basket here that is a prism. Okay? They both have the same volume. So this part's important. They both have the same volume. Okay, it says what is the height h of the rectangular waste basket? So that's this one right here. We want to know what the height is. Okay, well, first we want to know what the volume of the cylinder is. Remember, volume of the cylinder is pi r squared h. So first, we want to substitute in what we know. Okay, what we know is pi, right? We know pi. We can just leave that as pi. R, our radius, is right here. That's a. Okay, so we're going to do a squared times our height of this cylinder is 2a plus 8. So the volume is pi times a squared times 2a plus h for the cylinder. And now it does say that they both have the same volume. So if the volume of the cylinder is this, that means the volume of the rectangular prism is also that. So step 2 here, it says find the height of the rectangular prism with the same volume, pi a squared times 2a plus 8. And then the base, we've got, remember the base is 2a times 2a, which is 4a squared. Okay? So the volume for a rectangular prism is the base times the height. So if the base, or the volume is this, the base is this, how do we find the height? Well, we're just going to take the volume and divide it by the area of the base to get the height. So it's going to be pi a squared times 2a plus 8 over our base of 4a squared. Okay, so let's simplify this now. You'll notice there's an a squared in both of them that can cancel out. Now, we've got pi times 2a plus 8 over 4. This actually can still be simplified. If we pull a 2 out of the 2a plus 8 here, we end up getting 2 pi times a plus 4 over 4. Now we've got 2 and 4 that can now simplify to 1 over 2. So then this becomes equal to, I'm running out of room here, I'll write this over here. 2 divided by 4 is 1 over 2, so it just becomes pi times a plus 4 over what's left on the denominator, which is 2. So this then is your simplified form. This would be your height then of the rectangular prism. Okay, that's all for today. So that's lesson 11.1. Your assignment is on Math Excel. Go ahead and get on there. Now on Monday's video, I did mention that I was going to start doing live video conferences on Canvas once a week for your class. I'm doing this for every class. So the time slot for the algebra classes is going to be Fridays at 1 p.m. So this Friday at 1 p.m. will be the very first video conference Q&A session. If you have any questions over any assignment, you can feel free to come on by, ask questions. You can stay for 2 minutes and then leave if you want to. You don't have to come at all. It's completely optional. Even if you don't have any specific questions and you just want to come and hear what other people are asking questions about, you can do that also, if that's helpful for you. Or if you just want to come and work on your homework during that time and ask questions as you're working through the homework, you can do that too. I'm happy to help. So I'll be there from 1 p.m. to 2 p.m. every Friday, okay, starting this Friday. Okay, so if you have questions, feel free to drop by. Everybody will get an invitation to it on Canvas. But again, you don't have to come if you feel comfortable already with what we're doing. If you don't have any questions, you don't have to come. But if you do have questions or you just want to hang out, if you want to ask questions, you want to say hi, feel free to come by. I'm happy to help. Okay? So hopefully we'll see you guys Friday at 2 p.m. Go ahead and start on your assignment, which is on Math Excel. I hope you guys have a great day, and we'll see you guys later.